Okay, so we're going to start off talking through the fossil fuels. The first one that we're going to talk about is coal. Now, as I said earlier, coal basically comes from that really woody plant material, and it falls to the bottom of, say a swamp or an ocean or something, gets compressed. You've got basically the heat from the Earth's core cooking from the bottom. You've got pressure coming in from the top. It compresses it over millions of years, and you get this formation of oftentimes these seams. Coal usually comes in seams, as you see down in the picture down there. So that dark line is a coal seam. Now, the seams are found within the earth, obviously, and there's basically three primary ways that they go about mining for coal. There's underground mining, there's strip mining, and then there is mountaintop removal. So let's go over these real quickly here. Underground mining was the very first method used to mine for coal, and that's the ones you see in the old black and white movies where they have guys down there with the little lights on their heads and the pickaxes, and they go down deep down into these mines and they're chipping away at these coal seams, loading it into a railway car and sending it up to the surface, where then they send it out and put it in trucks and ship it wherever. Um, we have much better technology now. We still do underground mining to access these coal seams, but we now use something called a longwall miner. Now you'll see that there's a video link here on this slide, which is also on your slide that I shared with you. So make sure that you watch all these different video links, because it just gives you a really idea of what it's like and gives you some information. So this is what underground mining of coal looks like before versus these days. So it used to be these big long holes in the ground where we had these railway car tracks that ran through, and they'd chip out the coal, load it into the truck, and take it through. Now we use these longwall mining units, as you see over here on the right. And it's basically this machine that runs on a large track, and it's got these giant cutters on it, and they go in, they get to a seam of coal, and then it runs along and grinds out all the coal, and it gets put on a line and shipped out to the front. Now, the another way that we can mine for coal is called strip mining. And this is basically used when you have coal seams that are pretty close to the surface. And so the idea here is that you just kind of dig out and remove any of the overlying material so you can get access to that coal seam, and then you just basically scoop out those coal seams. Now, strip mining is also known as open pit mining because it basically ends up leaving a giant open pit when you're all said and done. It uses really, really big machines, big earth movers and all that. And so they're going in and they're swiping out, this all this earth to get down to the stuff underneath, and then they are able to get that coal out and then ship it out. It allows for more coal to be mined and using fewer workers because you've got these huge giant earth moving machines helping you. But then again, you're burning a lot of oil with all those giant earth moving machines. So, you're increasing your carbon footprint all that much more. Again, there's another video there on strip mining in the Appalachian Mountains. So take a look at that. It's a longer video, but if you just watch the first 3 minutes or so of it, you'll get a good idea. So here's pictures of what strip mining looks like. You can see that it's, right up near the surface. So they just dig down, 20, 30 feet or so, and they access these coal seams, and then they use these giant machines. These cranes you're seeing in both pictures, are immense, huge machines. And so they're just scraping out all the dark there is all coal. They're scraping all that out and they're loading it into a truck and they're sending it out to our coal-fired power plants. And then the third way that we can mine for coal is called mountaintop removal. And this one is probably the most destructive and the most controversial. It's basically when you go in and you basically blow the top off of a mountain to access the coal seams that are there in the rock. And then when you take off all the dirt, all the rocks and all that, you get all the coal out. And then when you're all done, you take all that dirt that you blew off of there and you try and, pat it back on top of there, kind of like it was a sandcastle, and make it look kind of sort of like it was when it started. Of course, you're never going to get that way because you're never going to get it compacted in the way nature created it. And there's a lot of problems that come along with this one. So as you can see from the slide here, you blast away and expose the coal. Once you've mined out all the coal, you try and put the top back. And then there's always excess rock and dirt because as much as you compact it down, you're never going to get it compacted enough to be able to put everything back. So what they do with this waste material is they dump it in nearby valleys. And the problem with that is that when you're blowing up rocks and all that, you're accessing minerals and metals and toxic elements like arsenic and mercury that have been held up in rocks for millions of years that normally would come out into the environment through a very slow process of leaching. But now you've blown up this mountain, you have all these rocks exposed, and then you throw it in a stream bed where water is going to be running over all the time, and you have all this leaching of toxic elements getting out into the environment. And so you have a lot of pollution issues with that. Um, you get exposed to really large levels of these contaminants, which damages not only the water systems and the people using them, but also the wildlife and the environment nearby. So again, another video there. Go ahead and watch that video. Gives you a really good idea. A lot of videos this week, but I'm hoping that helps you guys get some good visual ideas of what's going on here. Now, this is a picture of a mountaintop mine. You can see kind of the top of that hill. This is done oftentimes over on the East Coast because we have a lot of coal deposits over there, in the Midwest as well. Um, so it just kind of looks like they blew up the side of that mountain. When they're all done, they're going to try and pile it back up as best they can. The trees obviously aren't going to go back. They're going to hope that they kind of nature takes over. It's going to take a really long time. Now, there were some big issues in the past with this. The mining companies were getting in big trouble for taking this waste material and dumping it into the local valleys where they're having all these toxic heavy metals that have been held up in those rocks leaching out. And the locals were getting fed up. Their water systems were getting polluted. They were, their kids were having issues, their livestock were having issues, so they decided to start fighting back. They did the whole NIMBY thing, not in my backyard. Well, so in May 2002, under the Bush administration, Bush did some amazing things for our environment. He basically went in and had them change the wording from calling that excess material from waste material to fill material. And just by a simple name change, they're not changing anything about it, they're not processing it any differently, calling it fill material, now it was considered to be okay to go ahead and dump it in those stream beds. So the people fighting really had nothing to do. And you can see, you can click on the link there when you go through your PowerPoint on the rule change and read more information about it. Now, in addition to that happening, Cheney, who was Bush's vice president, also pushed under the Energy Policy Act, or excuse me, pushed the Energy Policy Act through Congress. And what this bill did was it allowed really large gas and oil industries to become exempt from parts of the Clean Air Act and the Clean Water Act. So basically, they were saying, hey, it's another way of subsidizing those really big energy companies, those oil companies, saying, you know what? Don't worry about all the environmental things. Just don't worry about it. We're just going to subsidize you because we want you to keep giving us a lot of oil and a lot of gas. So you're exempt from that. Not a really good idea. And we are, we very quickly started to see some consequences of that. And one of the reasons that I mention this is because in this class, one of the things that we really like to teach you guys is this is why your vote counts. The only way that you can get your voice heard is to get out and vote. Vote on the matters, educate yourself on the matters, get your voice heard. Speak to your local representatives and get out there and make a difference in what you really care about. If you want to see more pictures on mountaintop mining removal, there is more links in the PowerPoint so you can see those. So you can see the links right there, mountaintop mining in the Ohio Valley website. Now, this is a picture of the coal deposits, the coal reserves that we have in the United States. And there's currently coal mines in 26 states. So you can see a lot of them are either in the Midwest or more over on the East Coast. And they vary in the quality of coal they are, how far under the ground they are, where they're held up, and the types of mining that happen. But those are kind of all the pictures. You see, we don't have much in California, so we don't have a lot of coal mining going on here. Now, let's go over the pros and cons to coal. The pros is that there are vast reserves. In fact, the United States has the largest coal reserves in the world, and that's just because of the way the history of the Earth went. We had a lot of woody debris here and a lot of swamps and all that, and so we got a lot of coal formation. So we have more coal than any other nation, which is why 50% of our energy comes from coal-fired power plants. It's cheap for us to have because it's local. So that's the other pro there. It's very cheap. Now, you'll notice a lot of cons here. The con for all non-renewable energy resources is that it takes millions of years to form fossil fuels, and we are consuming them at a rate much greater than that. There's no way that nature could create these fossil fuels at the rate that we're consuming. You know, it takes millions of years. We're going through them in a few hundred of years. It's just not a compatible rate. Um, Another con, it's got to be mined from the earth. Wyoming and West Virginia are the two top producers, and a lot of times the mining is very unsafe. It causes a lot of environmental damage. I mean, way back when we first started mining, you know, people were going in and you see these pictures of these guys coming out just totally covered in black, and they weren't wearing any kind of respirators or anything. They were inhaling all this. There's a lot of natural gas locked up in coal seams, so they're taking in a lot of this methane and all that. They used to carry little canaries in cages. And then that's how they would know if they were running out of oxygen. As soon as the canary passed out, they were like, "Whoa, uh-oh," and then they would know to get out. So they held on to that bird the whole time. Um, that was sort of their indicator species, indicating that their environment was changing and they better get out of there because the room was filling up with natural gas. So, very unsafe for people and for the environment. Also, there's an awful lot of carbon dioxide that is released into the environment when you burn coal. So that contributes big time to climate change. As we learned in our last section in climate change, carbon dioxide is not the most potent greenhouse gas, but it is definitely the most prominent, most readily available one. And we are adding more and more and more carbon dioxide and offsetting that balance with all this coal and oil that we're burning. When you burn coal, it contributes to air pollution. And remember, going back to your air pollution section, you've got the two forms of smog. You've got the industrial smog and the photochemical smog. When you burn coal, you're getting that industrial smog, that grayish sooty color. And that's because when you burn coal, there's a lot of sulfur locked up in coal. And so you get sulfur oxides. Now, they talk about clean coal and reducing the amount of sulfur in it. It's not clean. There's a little bit less sulfur in it, but it's not clean by any means. The problem with releasing sulfur into the atmosphere is it becomes sulfur oxide, and as you know, that's a primary ingredient in acid rain, which is causing a whole lot of damage over on the East Coast. So having all these coal-fired power plants contributes to acid rain big time. Um, and as with a lot of our industries, they don't have to pay for the environmental damage that it causes. Okay, they're causing a lot of environmental damage, but they're not being encouraged at all, or not enough, in my personal opinion, by our government to switch over to more green resources. Our government really needs to start subsidizing these more renewable energy resources so that we are forced to wean ourselves off of these fossil fuels. And finally, something that comes as a big shock and a surprise to most people is any of you who are fish eaters out there, you probably know, mercury warnings like, well, you shouldn't eat so much tuna because it's got mercury in it and this, that, and the other. Well, have you ever wondered where does all this mercury come from that gets in it? How does it get in our fish? Yes, there's mercury locked up in rocks and that naturally erodes in the ocean, so you have some natural low levels. But actually, the majority of mercury that gets into our fish, as well as arsenic, comes from burning coal. Coal has mercury in it, and when we burn it in our power plants, it becomes airborne. But it's a heavy metal, so it has what we call a pretty early fallout. So it gets airborne, but it falls out onto the ground, and then as soon as it rains, the rain picks it up and carries it down into whatever watershed it's going into, and it eventually ends up in the ocean. And so you've got all this mercury in the water that gets into the phytoplankton, it accumulates up through the food chain, and you get bioaccumulation. So those larger fish species like tuna, halibut, all these other ones have these high levels of mercury because, they're eating a lot of the little fish that ate a lot of the phytoplankton that had some mercury in it, and it goes on up the food chain. So that's a test question there. Just hint, hint, you're going to see true or false, mercury in our fish primarily comes from coal-fired power plants. The answer is true, it does. All right, in our next video, we're going to discuss oil.